All right, welcome to our kind of pre-lecture, our very beginning discussion for IA 208, PLC 1, Harrisburg Area Community College. This is Robert Ferguson. We want to start with a step back before we dive into the course material. We want to talk about what a PLC is anyway. We all know what PLC stands for because if we purchased our book, right at the top, we know that PLC stands for Programmable Logic Controller. So what is a PLC? What the heck is it anyway? What is a Programmable Logic Controller? Well, honestly, a PLC is simply a computer. Very, very simply, it's a computer. It's a very simple computer. However, what makes it a PLC versus a computer of some other sort is it's specialized. It's a specialized computer, and it's specialized in certain ways. So the definition of a PLC is it's generally specialized for industrial use. Okay, so what is a PLC? What specialization makes it useful for industry? So let's talk about that. A PLC is an industrial computer, and in general, what makes it useful for industry is it can connect to inputs and outputs. Inputs and outputs. In other words, it can be hooked up to something that gives it input data, for instance, a switch, which might be on or off, and it can be hooked up to output data, something like it could turn on itself, like a solenoid valve or a light. It can turn on a light. And so it can have inputs and outputs. And one way that it can be reliable for inputs and outputs is because it has industrial, I would call it buffering. It's protected from all that high voltage, spikes, electrical noise, all that very bad stuff for computers that happens in a manufacturing facility. So it's got industrial buffering. It is isolated. In the terms of the electrical terms, we call that isolation, generally using something called optical isolation. That means they use the special chips in this buffering layer that physically disconnect the two wirings, the internal wiring of the PLC from the external wiring of the real world, all those switches and motors and all things that can go shock you out in the real world. You've got these optical isolation chips, which means that you're using light energy to transmit data instead of electricity, that optical isolation. So it's got inputs and outputs, it's got buffering. Those are very, very important design criteria for a PLC. It's designed for manufacturing. Another thing is physically, it's tough. It's designed to be mounted inside of a panel. It's designed to handle heat and cold. It's generally physically tough. It can handle a bad environment. So these are all physical characteristics of a PLC. Inputs, outputs, industrial buffering, and tough. So what are some of the software characteristics? Like, we all run into problems with Microsoft Windows, right? We know Windows crashes pretty often in some cases. That's gotten more reliable over the years. And we know that sometimes it runs super slow for no apparent reason. We know that if we go onto the wrong website, we might catch a virus that'll basically crash the computer and destroy all of our data. We don't want any of those things in industrial application, where reliability is absolutely the most important factor. Reliability needs to be most important. So you need a specialized operating system. Right? That specialized operating system has to be highly reliable. It has to be very, very reliable. And part of that reliability is they've got something called a watchdog. Sometimes called the watchdog timer. It's a special little software component that just checks up on the operating system running properly. And if the operating system is running too slowly, you know, unlike your Microsoft Windows PC, if it starts slowing down, ain't nobody going to notice but you, and you start cursing at it. But a PLC, it's got its own software built in called the watchdog, and that watchdog will start barking if it slows down and will cause special actions to occur, to reboot it, to warn the operators, to do some other things, whatever you program it to do. And the other thing is it allows for certain PLC software. And there's several different kinds of PLC software. All of them loop through a program over and over and over. They keep looping through that program, performing those actions over and over and over. And that looping program, that constant checking of inputs and outputs and performing actions and calculations, that loop is part of all PLC programs. And we're going to learn it in this course. We're going to learn one particular language called ladder logic. And ladder logic is unique to PLCs. It's probably the most common way of programming PLCs. And we're going to learn about that method today. And this super reliable, hardened input and output, buffered, tough system is a PLC.